Our course of crystallography and mineralogy will help us know many things about crystals, their growth and their shapes, and then how they form minerals. Then this will help us in our course uh, of rocks. So that we need to know about crystallography to just define minerals and crystals. To see what is mineralogy is just a science of studying the minerals, comprising, of course, crystallography and mineral chemistry, economic mineralogy, and this will lead us to know what is mineral. Mineral is just a natural substance. It's an inorganic, solid, with characteristic chemical composition and crystalline structure. To understand the mineral structures and its properties, this will answer our questions about why quartz, for example, and diamond are so hard, and why solid granite is rock, or why solid granite rock is uh, destined to become soft, sticky clay. Minerals are natural resources, providing raw materials for many industries. So it's very important to understand minerals that has a geological and as well as economic application. When it comes to the definition of crystallography, and you see this figure, before going to crystals, we know the atoms, and those atoms they have relationships to each other, and they are connecting by bonds. So crystallography here is a study of crystals. It includes the study of crystal form, crystal structure, and crystal symmetry. And it is a part of the science of. So crystals are solid, and they are formed by regular repeated pattern of molecules connecting together. In some solids, the arrangements of building blocks, the atoms, here the building blocks means atoms and molecules, can be random or very different throughout the. But in crystal specifically, we have something called a unit cell. It's a collection of atoms and it is repeated in exactly the same arrangement again and again throughout the entire material. And whenever we have like slow cooling of liquid, this will allow atoms to arrange themselves into an ordered pattern, which may extend of long range million of atoms to create crystalline. So crystallography in our science of geoscience, um, we know most of the Earth is made up of solid rock, and the basic unit from which rocks are made are minerals. As we have said before, the basic unit from which minerals are made are crystals. So we have atoms, then we have crystals, then crystals give us minerals, and minerals create or you know create rock. So there are, we have like over 400 recognized mineral on this earth. As many as 100 new ones are described each year. For example, large-scale processes such as rock formation, deformation, weathering, and metamorphic activities are controlled by small-scale processes such as movement of atoms. When we move to the structural properties of a crystal, you will see all minerals are crystalline structures made from a mixture of different elemental compounds. As you see from this figure, So the crystal's growth pattern is referred to as crystal habit. And in this example, you will see the crystal habit or crystal structure of diamond and graphite. So when it comes now to shapes of crystals, you will see some crystals, they have very good shape, and some others, they have just some of them, some edges are clear and some are not. So that's why we classify crystals in terms of shape as a euhedral, anhedral, and subhedral. So anhedral, which doesn't show very clear faces or edges, we call it irregular or anhedral. So it does have only little or no evidence for its own growth, as we see in figure A. Subhedral partly bounded its own growth phases. Some phases only appear, or growth phases only moderately well developed, as in figure B. And euhedral, so we have complete phases, grains bounded by its own perfect to near perfect crystal growth phases. In our next lecture, we will be talking about the crystal systems, and we will know more about the axes and symmetry and stuff like that. See you next lecture, and bye.